In this lecture, let's talk about the use of limestone in industry during and after the Industrial Revolution. In the process of making pure iron metal, two ores are used. One is magnetite and the other is hematite, magnetite being Fe3O4 and hematite being Fe2O3, both of which are iron oxides. The iron is removed by reacting carbon in the form of coal or coal coke in a displacement reaction within a blast furnace. Here the carbon takes the oxygen and becomes CO2 gas, and the iron is left as a pure molten liquid below. However, one of the main impurities within the ore is that of silicon dioxide, otherwise known as sand or silica. This does not react with the carbon and therefore presents a problem. However, with the help of calcium oxide, the sand is removed as CaSiO3 or calcium inosilicate or slag. This floats above the molten iron and is easily removed. The biggest example of this process, here in Wales, is at Tata Steel's Port Talbot Steelworks. Another use is that of concrete. Here, calcium oxide can be mixed with aluminum or iron oxide, which is an aggregate, sand and water to make mortar. If only sand and water are used, this makes cement. This mortar is used to put bricks together, which forms walls and houses and many other buildings. It can also be used in infrastructure projects, like the building of bridges and pavements, but is also used to make roads. These are formed by laying down a layer of concrete and then adding bitumen or asphalt, which is a thick tar-like substance extracted at the bottom of a fractional distillation of crude oil. Some of the first roads built like this were circuits, with the Indianapolis Speedway doing this in 1909, and in 1961 after being replaced with bricks. Another famous circuit to use concrete was that of the Autodromo Nazionale di Monza, which hosts the Italian Grand Prix each year. In the 1930s, the circuit built up an oval circuit with large banked corners at each end. These were pure concrete and are seen here. However, this setup was very dangerous and killed many drivers and spectators, most notably that of Alberto Ascari and Jochen Rindt. I've been selling you on the amazing material that is concrete, but there is a dark secret here. When the calcium oxide is made, it releases CO2 into the air, and with the large amount of concrete being produced each year, it's probably the most polluting industry in the world aside from those that burn fossil fuels. There is an upside to this though, as we know that this reaction is reversible, and concrete degrades over time to trap CO2 as limestone. Finally, we have the more mundane uses. One use is to change the acidity of soil used to grow crops. Seeing as calcium carbonate is a mild base, it can react with any acidic residue left over from previous crop growth and turn it into a neutral salt, water, and carbon dioxide. Speaking of neutralizations, how about you try and balance this reaction out between phosphoric acid and calcium carbonate? All done? Well, we have 2 phosphoric acids and 3 calcium carbonates, make 3 waters, 3 carbon dioxides, and a Ca3 bracket PO4 bracket 2. A few other uses is that of antacids, because it can neutralize stomach acid, and in toothpaste.